e power minus j omega kt. We know that x star of j omega is sigma k is equal to minus infinity x of kt into e power minus j omega kt. So if I replace this here, if I represent this here, integral minus omega s by 2 to omega s by 2 e power j omega t into sigma k is from minus infinity to infinity x of kt into e power minus j omega kt d omega. Okay. Now we can say that x of t can be given as 1 by omega s in 1 by omega s sigma k minus infinity to infinity. You can, without any loss of generality, you can interchange the integration and summation. Therefore x of kt integral minus omega s by 2 to omega s by 2, you can say e power j omega t, e power j omega t and e power minus j omega kt into e power minus j omega kt d omega. So we have this as 1 by omega s sigma minus infinity to infinity x of kt into minus omega s by 2 to omega s by 2 e power j omega t minus kt d omega. So now we will try to integrate only this part. You will have e power j omega t minus kt by j t minus kt, because it is with respect to d omega, and you have it from minus omega s by 2 to omega s by 2. Now with this in mind, we can say I will also, this is x of t, which is 1 by omega s sigma k minus infinity to infinity x of kt into this one. Therefore this can be represented here, which is equal to 1 by omega s sigma k minus infinity to infinity x of kt into e power j omega t minus kt. Instead of omega, you replace omega s by 2 and omega s by 2. I can also consider j t minus kt is a constant with respect to omega. Therefore I can remove this into 1 by j t minus kt, and only this part you can substitute omega s by 2. You can say it is e power j omega s by 2 t minus kt minus e power minus j omega s by 2 t minus kt in this form. Therefore we are having this as 1 by omega s sigma k is from minus infinity to infinity x of kt into 1 by j t minus kt, and this is e power j theta minus e power minus j theta. You have c plus j sine minus c minus j sine, you have 2j sine. So 2j sine omega s t minus kt by 2, right, and j and j gets cancelled, and 2 by omega s, I can also substitute this as when minus infinity to infinity x of kt into omega s can be considered here sine omega s t minus kt by 2 by 2. If we bring it to the bottom and omega s inside, I can have omega s t minus kt by 2. So with this you can say that we are having the continuous time signal which is reconstructed back x of t. The continuous time signal is reconstructed back, which is equal to x of t, which is nothing but sigma k is minus infinity to infinity x of kt into sine omega s t minus kt by 2 by omega s t minus kt by 2. So this is happening only when omega s is greater than 2 omega 1. This indicates that sampling theorem holds good only when the condition sampling frequency is greater than 2 times of the highest frequency component omega 1. Only then you are getting this function. And x of t is the reconstructed continuous time signal from x of kt. You are getting a continuous time signal. X of kt is a magnitude at various instants and sinusoidal terms you are having, and therefore you will be getting a continuous time signal here.